Why is the sky blue?
So the answer is easy to understand, it's just not simple.
First of all, is the sky blue?
Yes.
Okay, well, at least we got that out.
Does it look blue to you?
It does.
Fine. That's what we're about to talk about.
All right.
Okay. So, here's the deal. The explanation is actually simple. It just takes a little while to explain.
Okay.
That's all.
All right.
So, we have an atmosphere.
Okay.
We all know this.
Yes, we do.
Okay. It's composed primarily of nitrogen.
Okay.
It's 78% nitrogen, it's 21% oxygen, and a few percent other, carbon dioxide, this sort of thing. Mixed in there are particles of like pollen and dust and sand from sandstorms and pollution and smog and so
Particulates.
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 Okay. Now, light comes from the sun. White light. People say the sun is yellow. It's white.
Right.
Okay.
Exactly.
You've seen the sun in the middle of the day. It's white.
It is white.
Okay. That's the proper color of the sun in the middle of the day. So, you may remember that white light is composed of colors.
Right.
Okay.
Put it through a prism.
That's how you get a rainbow.
Right.
Or you're educated. You said prism, but through a raindrop, it spreads them out into colors.
Right.
And you get the colors of the rainbow. Roy G. Biv.
Okay.
Red, orange, yellow, green, blue.
Indigo, violet.
Okay, so 7 colors of the spectrum. Okay,
Right.
if you, the way our brain works and the sensors in your retina, okay, the rods, the cones. Yeah, the rods give you shades of light and intensity. The cones disentangle color.
Okay.
Okay, and you have an RGB cones.
Nice.
Okay, so we get RGB from.
Right.
You've heard that in computers and
right.
the computer screens and everything. Okay, so you are chemically, with the chemicals in your retina, splitting that red light into combinations of red, green, and blue.
Okay.
Okay? Broad combinations of these 3. If you have more red than the others, what you look at is going to look more red to you.
Right.
If you have more blue than the others, it's going to look blue. Now here's what happens. White light comes down from the sun. The particles in the atmosphere, some of them are about the same size as the wavelength of blue light.
Sweet.
All right, now if you have a particle and light, and there's a particle that's the same size as that light, it'll reflect.
That's right.
Or scatter, that's the proper word, okay? Bounce, scatter, and so that light doesn't make it straight through. It sends in every other direction.
Ooh.
So the light from the sun selectively has the blue removed on its way down to Earth's surface. And the blue scatters into the air, and you have a blue sky.
That's very romantic.
It is beautiful. Now, it's called Rayleigh scattering. So here's the thing. As the sun gets lower in the atmosphere, the path length of the light is much longer through the air. Okay, so in other words, so here's your atmosphere. If you're directly above, you're going through like this thickness. As you come down, the thickness gets more.
Right.
Okay?
Right.
Well, more atmosphere, more scattering.
Right.
The sky gets more blue. Okay? So in the daytime, it's, quote, sky blue. That's actually a pale blue.
Right, it's a very pale blue.
As you go to twilight, that sucker gets deep.
Yeah.
It gets deep blue. And so much more blue gets taken out of the sun.
I just love how violent deep blue is.
It's deep. And if you take out that much blue, the sun ain't got no blue light left at all. So what color is it gonna turn?
Kind of red.
Kind of red.
Kind of red.
Kind of red, amber.
Yeah.
Okay? That's why sunsets are red.
Oh, that's
Because so much blue was taken out.
right.
That's all it has left to give you is the side of the spectrum where you have red, orange, yellow.